Hi, welcome back to SP Live and today's show, Reservoir Engineering Application in Unconventional Reservoirs. It's great to be here with you. My name is Niels Korgersen-Loe. It's my great pleasure to be your host today. So today we are taking a look at ATCE 2020 and previewing one of the hot technical sessions, namely Session 20, Reservoir Engineering Application in Unconventional Reservoirs. Joining us shortly will be Session Chair Neha Bansal and two authors of technical papers in the session, Ghazal, Dashti and Garrett, Lindsay. What's the session about? It's really about the unconventional resources that have transformed the landscape of the oil and gas industry around the world. And knowledge and characterization and optimized development of these resources has been growing over the years. And this session at ATCE will focus on advancements in reservoir engineering aspects with discussions on well performance, well testing, fluid characterization, infill well characterization, and integrated reservoir modeling. So without further ado, let's meet our guests for today. So joining me on today's show are Neha Bansal, Ghazal, Dashti, and Garrett, Lindsay. So Neha Bansal, she is the ATCE Session 20 Chair and also the Reservoir Engineering Committee Chair for ATCE 2020. Neha has been working with reserves assessments at DeGolyer and MacNaughton since 2020, and in particular looking at reserve assessments and appraisals, prospective and contingent resources assessments, reservoir simulation and production enhancements for DeGoyer's North America business division. Prior to DeGolyer, Neha worked at Anadarko as a reservoir characterization supervisor and reservoir engineering technical lead for the Delaware Basin development. Joining her today is Ghazal Dashti, senior reservoir engineer at Chevron, her career spanning over 10 years in reservoir and petroleum engineering. Ghazal leads a team of reservoir engineers and simulation engineering efforts for Chevron's MidCon business unit, where focus areas include surveillance, microseismic, data quality checks and history matching, completion optimization, well spacing, pad sequencing, depletion, and well landing optimization. Ghazal also leads the kinetics Petroleum intersect workflow application for the MidCon business unit. She completed a Master's of Science in Petroleum Engineering from the University of Texas at Austin. And finally, on today's show, Garrett Lindsay. He's a petroleum engineer at W.D. von Gonten and Company since 2018. Earlier, he has spent 11 years at Schlumberger as a senior production and reservoir engineer, evaluating risk-reward structured business opportunities and related to fracking and production enhancements and field development in unconventionals. So welcome to all of you to the show. It's great to have you here.
Thank you for having us.
Yes, thank you.
Okay, so we are talking about unconventionals and reservoir engineering applications in unconventional reservoirs. So this is session 20 at this year's ATCE. A particularly hot topic, I would say, reservoir engineering and also the combination of unconventionals, particularly in the current market environment. So Neha, let's start with you. Tell us, first of all, your committee's approach to creating this year's reservoir engineering sessions at ATCE.
Absolutely. Thank you for that question. So firstly, I've been working on the ATC committee for a few years now, and the approach is usually governed by what is relevant for the industry at the moment. Additionally, ATC is a highly selective event with acceptance rate for abstracts to final presentations in the range of 10 to 12% for reservoir engineering discipline alone. We have a very experienced and diverse set of committee members who work very hard throughout the year to make sure that the best papers get presented for the event. In the sessions, we try to balance topics that are important for companies and academia to make sure there is something useful for and interesting for everyone and for all the attendees. So in this year, we have topics ranging from development plan case studies to advancement in well testing and forecasting, reservoir simulation, improved oil recovery, and of course, reservoir engineering applications in unconventional reservoirs. And we hope as a committee, there is something interesting for everyone.
Thanks, Neha. So more specifically about session 20, give us some of the details of that particular session and its relevance.
Sure. Absolutely. So, in terms of relevance, I think you gave a good background, anyways, introducing the session. But just to give a little bit more details around that, so unconventional oil resources have played a very important role in our quest for energy security over last decade or so. But our knowledge in how to best develop these plays is still evolving. Everyone is still learning from every play, every company, and every challenge that is thrown at us, including the major shut-ins that everyone faced because of the oil price decline again this year. So most of the operators in this industry with respect to unconventional reservoirs work with the challenge of balancing between the technical aspects of optimal hydrocarbon recovery and the economic aspect of optimal financial matrix. So all the topics that we have in this particular session we'll be discussing will have relevance in development of these reservoirs, and I believe would be very useful for most of the people working with these plays.
Okay, thank you very much. So there you were talking about well shut-ins and optimization of operations to maximize recovery. So in addition to those, what else are some of the sort of expected takeaways from this particular session for viewers that will be attending?
Absolutely. So I again wanted to re-emphasize, first of all, remember that for any of the sessions, only top 6 to 8 abstracts on that particular topic make it to the session. So it's a very competitive process to begin with. And then because of that, I would expect to see very important and relevant work being discussed on the platform. We'll have topics such as well performance, well test, fluid characterization, infill well characterization, integrated well modeling pertaining to unconventional reservoirs. And then even with a virtual setup this year, we are trying to give opportunity to the audience to ask live Q&A as well.
That's excellent. I mean, I've been looking at the session itself, and as you say, there's some really good content coming up in there. So very excited to see that and to participate. Just again, you touched upon the virtual environment. So, you know, it's something relatively new for this year. So for everybody, what have been some of the challenges of putting together a virtual session?
So if I start going through the list, I think it's going to be fairly long, but I'll try to keep my answer a little bit concise. So once we have decided on a platform to host the conference itself, then the key issue as the committee chair in my mind are creating commitment and presence from the audience itself, because in the past, when you're having a in-person event, the presence of the audience is the commitment part. Now everyone is virtual, so commitment and presence is one of the key challenges. Then the other part is giving the audience the opportunity to build relationships, which is a networking part, a big part of these conferences. And lastly, the audience participation, because that's, again, very important for the whole process of presenting and then getting feedback from the audience. So in addition to it, for most of us, this is the first experience as organizers or presenters and attendees in a virtual format. We have tried to create a very smooth process with pre-recorded presentations and live Q&A sessions, like I said. And I really hope we can all make the best of it until we can go back to safely meeting in person for these events.
Oh, thank you very much, Neha. And I will actually sort of re-emphasize some of your comments there. So, you know, the pre-recorded presentations, they tend to be very high quality because they are pre-recorded. And the fact that you have a live Q&A session allows people to really, as you say, get committed and be present in that discussion. It's a very, very democratic process. And people are able to ask questions as they see the presentation going. So you can build up a bank of good questions and good discussion. So that really builds that quality discussion at the end of the presentation. So looking forward to that. Let's turn to you now, Ghazal, and your paper that you'll be presenting, Depletion Effect, Quantification and Mitigation of the Offset Wells. So complicated title, very interesting title. Give us some of the background for your paper, please.
Absolutely. So this paper is about a methodology that we came up with to estimate depletion effect, which is basically occurring when a well is completed next to an existing producer. It's essentially because the wells are not really completed and produced at the same time. The depleted wells are called the parent well, and the new wells are usually called the child well. So in the field, the parent well happen when there is a single well that is drilled next to an existing well, right? In the middle of the section for the lease retention, for example. Or there is another scenario. There's a competitor well produced nearby the boundary. Or even wells on the earlier pads in the same section are put on production. Now, we're using an earth model in this study to simulate hydraulic fracture reservoir simulation. And we used it as our base model. We performed sensitivity analysis and validated against multiple field data. So in the paper, we came up with a calculator to make a fast estimation of this depletion effect. There's going to be some economic analysis associated with this study too. So
very interesting. So I'm pulling from that, you're using an earth model to simulate the fracture distribution, and then you have a calculator to do some looking at the economic consequences of this parent-child interaction. So obviously there's an inspiration to this work. What is that? What in sort of for the everyman?
Sure, definitely. So this paper originated from the fact that there have been many operators that were on production ahead of the time, ahead of the neighboring well, and this caused a discount factor on the new well performance. Now, this concept was very new when we started working on it, trying to find a way to quantify the production loss using this methodology, which is a hydraulic fracture reservoir simulation. And we wanted to come up with a methodology that can estimate this effect and, quantify that for the parent-child effect or the depletion factor, which is going to hurt and, that producing well.
Okay, thank you. So what then is going to be sort of so for the viewer, what are they going to get from this presentation? What's the end user going to get?
So I guess reservoir engineers, of course, and completion engineers will need to get a sense of production loss and how they need to come up with that when they're drilling next to an existing producer. Even operators like drilling, they're also benefiting by knowing how much they're expecting to have a production loss. So this is going to be helping them to think ahead and expect the production loss. How much is that? And is it economical or is it not?
Okay, thank you. And some of the novelty in your work, is that the calculator or the combination of the calculator and the earth model, for example?
It's both of them. The earth model, the methodology that we came up with the stress and pressure being the base of the case after running the model, and then after many years of production, putting it on run, and then come back to that and reanalyze it and refrac it. So this is one of the novelty that is pretty new concept. And also the calculator itself was based on all of these runs in the reservoir simulation model. So that calculator was also another piece of the novelty.
Thank you. That sounds very exciting, Ghazal. So I'm looking forward to listening to your presentation also. And it neatly brings us to Garrett. So your paper, the presentation you're giving it, is on unconventional measurements, bootstrapping reservoir simulation. So Garrett, first of all, what do you mean by bootstrapping reservoir simulation?
That's a very fair question. Outside of just kind of a clever message, one of the guys or co-authors in the paper likes to create clever title names and stuff sometimes. But our point was, I guess, being in reservoir simulation, you often find there's multiple parameters that you can change in order to get a history match. And so using actual core measurements and stuff like that from the actual core, we feel we can do a better job, if you're using these measurements to help remove some of those parameters and those, leaving the parameters with the most uncertainty, those become kind of your primary history match parameters.
Okay, so core measurements and then how that builds into history matching. So relatively conventional technology for a conventional field, but not particularly usual for these unconventional. So what's the inspiration then behind the work? Is it to actually get better characterization?
Sure, that's a good question. So for us, it seems like historically, or with current commodity prices, operators have had to cut costs so much that the main focus has been on surface operations, mainly completions and drilling. And there's not a lot of time and effort spent on understanding the actual reservoir aspects for the actual reservoir rock, meaning, the flow and deliverability through the nanopores and the compatibility of completion fluids with those nanopores. So here we actually have a lab where we actually take core and we're doing these measurements on the core samples, and we put a lot of focus in on those reservoir measurements. And so some of the things that we're trying to answer is, how come we go out and drill a well or multiple wells, we're only getting 10 to 15% recovery factors in these wells? We see operations side, they're going from the very close cluster spacing, very tight well spacing, and increasing the job size, but all we see is production degradation, but we're still not increasing that 10 to 15% recovery factor. And so we don't know, but I think that's what a lot of our effort has been in spending, trying to understand what happens in these nanopores. And so kind of going back to the question, from a conventional to unconventional, it seems like our first assumption had been that, as you remove a core from the surface, you often have this void space by the time you get to the lab. And the assumption that it was evaporated hydrocarbon has been incorrect. And what we found is that it's actually a combination of evaporated hydrocarbon and evaporated water. So what that means, we might be underestimating our water saturation, but overestimating our hydrocarbons in place.
Wow, that's a very important conclusion to be bringing out. So apart from that important message, what else will the viewer gain from your presentation?
Sure, absolutely. In addition to that measurement, we've also found that, as you measure, so this is a core sample, we've actually measured the deliverability using hydrocarbons. So we've done a better job at understanding the actual permeability to the nanopores using liquid permeability steady state testing. But we inject completion fluid on the opposite side to understand, when we inject hydraulic fracturing fluid at 2,000 psi above reservoir pressure, we often see that it imbibes into the pressure face of the rock. And so we're measuring that. And then how do we incorporate that into a reservoir simulation model? And so we discussed this quite a bit in the paper, but that was one of the biggest challenges is you've taken all these measurements, and so it kind of changes. We've had to divert to a unique multiple porosity model, but we were able to obtain much better matches, especially when build-up data is available.
That's excellent to hear. So a real sort of marriage of petrophysics and reservoir engineering and history matching. So I certainly look forward to hearing your paper and presentation as well. That sounds excellent.
Yes, sir.
Now I'm going to open up to a short discussion with all three of you. So I'm going to throw a question out there to all of you. So one of the challenges, I guess, with unconventionals has been reservoir management. We've been very good at reservoir management and developing reservoir management knowledge and competencies in conventional fields. How, for example, is this session going to help bring reservoir management skills and practices into unconventionals, which has been largely a factory-based operation to date? Neha, perhaps we start with you in your session.
Sure. And very good question and very relevant, obviously, in these times in general. So one of the things that I've noticed being a part of the operator world as well, now I'm working in a consulting firm, is that since with unconventionals, it's hard actually to drill a dry hole, we get complacent. And that's why this factory mode really catches on, where we want to drill as many wells as we can, as efficiently as we can, as a function of the price that is there in the market at the moment. But as soon as a new challenge is thrown at us, then whatever is the playbook for last 6 months goes away, and then we have to reinvent ourselves. So as an operator and as a learner in this industry, I think we in unconventionals need to learn from our mistakes and not repeat them. Because every time like there's a shut-in or there's an oil crash, something like that, let's not repeat the things that we have done in last 5 years. I think that's one of the things I would say to everyone. That's the way to learn, because the stakes are very, very high.
Thank you. Okay. Ghazal, would you want to add to that?
Absolutely. When we are talking about reservoir management, it reminds me of subsurface characterizations and the area that I have been working on. So I have been working in conventional and unconventional. And when we started off by using some modeling efforts, it was extremely challenging to model a fracture area But nowadays it's not it, and it's more noun subject, but it has a lot of room to grow. So as far as the concept of the conventional going to unconventional goes, the subsurface characterization is still growing, and it needs to be growing. And that's my intake. And I think that we are seeing it in many papers that there is a room to grow still in that regard.
Yeah, so an important message, that subsurface characterization, and that goes back to you, Garrett, and what you were saying earlier. So you want to add to that, perhaps?
Sure, absolutely. I mean, I completely agree with Neha and Ghazal. As an engineer, you can never have too much data, and so the challenge has always been in the field, especially with unconventional operations. You have so many wells, the cost you want to cut, and so you just want to hook a well up to the pipeline. But sometimes, even beginning from the allocation back to the single well, back to the subsurface, and then you have 10, 15,000 foot of lateral, trying to understand where it's coming from, which portions are contributing, and how that changes dynamically through the life of the well. It's very challenging. So, I mean, without having better data, I think we still struggle to understand how these fluids and hydrocarbons flow through these nanopores to the well.
Yeah, absolutely. So I was just going to add to that question and sort of go back again. And so, Garrett, you earlier mentioned EOR and recovery factors of 10 to 15%. So, overall in this session, EOR is going to be an important piece, as well as operational efficiency. There's going to be topics that come up and people are going to ask questions. So what to you, Garrett, are going to be some of the things that you take away from this session in terms of understanding or moving the industry forward on EOR and operational efficiency?
Sure. So, I mean, kind of stepping outside the scope of our paper, but there's a lot of EOR done in Eagle Ford and a lot of success down there by a particular operator. There's been some replication of that process, but the challenge is still that EOR is expensive at this time. So as technology develops, the cost of pumps being so large gets to be expensive. So as commodity prices increase, I think there'll be a lot more trial and error, and there'll be a lot more application to EOR techniques and trying different things.
Thank you. Ghazal, do you want to add to that, considering all the work you're doing on the parent-child interactions and Earth modeling?
Sure, definitely. As far as the EOR goes, I definitely agree with this statement you made. It is expensive at this time, but it has a pretty good potential. And specifically for parent-child well, this could be an opportunity to enhance and kind of try to fulfill the missing production or the production loss. This could be a methodology to capture that.
Well, thank you. Neha, you're chairing this session, so what are your big hopes for people in terms of coming away from your session having a better understanding of operational efficiency in EOR, for example?
Sure. I think the overall goal with any session, and this session in particular, especially pertaining to unconventional reservoirs, is since unconventional reservoir development is such a big topic, we want to try and hit every key aspects that is relevant to operators as well as the academia people at the same time. So that's why we have such a good mix of fluid characterization, EOR enhancement, well optimization, reservoir characterization, everything in one go. So my hope is really that there is something for everybody, and good quality something for everybody, because there's a lot of work and effort that goes in from the committee itself, and more so from the presenters who actually submit the abstract, create these papers, work so hard to actually put together a presentation, go live, and answer your questions. So that's really my hope.
Yeah, absolutely. And what you were saying there about the work and effort that goes into this and the quality of the technical presentations and technical information, I think is just paramount, and obviously the priority for the whole conference. So absolutely. I'm certainly very much looking forward to your session. It's already making me itchy with anticipation and excitement. So thank you very much. And thank you very much to the three of you for joining us today to talk about the session 20 at the ATCE on reservoir engineering application in unconventional reservoirs. And that session you can join, so Tuesday, 27th of October from 1:30 to 5 o'clock. It's in session room 10, so that's a virtual session room 10. But please check out ATCE on atce.org. Join the conference, join all our presenters and session chairs in a very excellent conference. So once again, Neha, Ghazal, Garrett, thank you very much for joining us today. It's been an excellent conversation.
Thank you for
having us.
My pleasure.
Thanks.
Thanks for having us. Thank you.
Thanks. Bye.
Bye.